trigonometric ratio is just a ratio that we use to find missing side lengths in a triangle, and the triangle has to be a right triangle. So before we talked about special right triangles, and that was when we had a 30, 60, 90 triangle or a 45, 45, 90 triangle. And the other way we could use to solve right triangles for missing sides was Pythagorean theorem. But now there's one more way to solve right triangles, and that's called trigonometry. And trigonometry stands for triangle measure. So the way we're going to use it, let's look at triangle ABC here. ABC is a right triangle. The sine, cosine, and tangent functions of a right triangle is a ratio that's used to find missing sides or angles. And before we find out what the sine, cosine, and tangent of the right triangle is, we have to find out what we want to use as our reference angle. The cosine function of our angle is equal to the angle's adjacent side over the hypotenuse of the triangle. The sine function of an angle is equal to the angle's opposite side over the triangle's hypotenuse. Let's go ahead and write these out until we're more familiar with them. And the tangent of an angle, depending on what angle we're using, is equal to the opposite side to that angle over the adjacent side to that angle. So let's say that we're asked to find the tangent of angle A. The tangent of angle A is going to be the side opposite angle A over the side adjacent to angle A. If we use B as our reference angle, we want to use the tangent of angle B will be equal to the angle B's opposite side over angle B's adjacent side. So the reference angle is just what angle are we using to set up our trigonometric functions. And our reference angles are only going to be the acute angles of a right triangle. We're never going to use the right angle in a right triangle as our reference angle. Okay, so example 1, we want to find the sine, cosine, and tangent of the indicated angles, or the reference angles. So let's say I want to use angle D as my reference angle. So the sine of angle D, remember sine is equal to the opposite side over the hypotenuse. So the sine of angle D is going to be angle D's opposite side, 14, over angle D's hypotenuse. Well, the hypotenuse of a right triangle is always opposite the right angle, so it's going to be 50. The cosine of angle D, we're still using angle D, the cosine of angle D is going to be the side adjacent to angle D. That means the side that is touching angle D, but that's not the hypotenuse. Because you'll have to remember that the hypotenuse will also be touching angle D, but we've already given this side a name, and it's called the hypotenuse. So 48 is the side adjacent, or the side touching angle D. That's not the hypotenuse. So that's 48. And then of course the hypotenuse, the side opposite the right angle. Okay, and once again, let's look for the tangent of angle D. Well, we're going to use angle D once again. Tangent is equal to angle D's opposite side, so across from angle D, which is 14, over angle D's adjacent side, the side that's touching angle D, but that's not the hypotenuse. So these three ratios represent the sine, cosine, and tangent ratios of angle D. So now I'd like for you to try finding the sine, cosine, and tangent ratios using angle E, this angle right here, as your reference angle. Okay, let's start with the sine function. Go ahead and pause the video and see what side is opposite angle E over hypotenuse to the triangle. Okay, well the ratio you should have gotten is 48 out of 50. Now, as soon as you see the hypotenuse of a right triangle, go ahead and just put an H by it, because the hypotenuse is never going to change. It's never going to be an adjacent side, and it's never going to be an opposite side. So if you just write an H next to it, it doesn't matter what angle we're using as our reference angle. This will always be the hypotenuse across from the right angle. Now we're using angle E as our reference angle, so opposite of angle E is across from angle E, and that's 48. And of course we said the hypotenuse was 50. All right, now we're going to use angle E again as our reference angle, but this time we want to find the cosine ratio. The cosine of angle E is equal to angle E's adjacent side over the hypotenuse. Pause the video and see if you get what I get. Okay, the ratio you should have gotten is 14 out of 50, and cosine of E is our reference angle. So E being our reference angle, we want to find the cosine. Cosine equals the adjacent side. Adjacent means the side that is touching the angle but is not the hypotenuse, so that's 14. And then of course the hypotenuse, which we label because it's across from the right angle. Alright, and finally, using angle E again as your reference angle, I'd like for you to find the tangent ratio. And pause the video and see if you get what I get. Okay, so you should have gotten 48 out of 14. The opposite of angle E is across from angle E, that's 48. And adjacent, the side that's touching angle E, but not the hypotenuse, is 14. Now if you notice, the sine function changes depending on which angle you use as your reference angle. So the sine function of angle D is 14 out of 50, but the sine function of angle E is 48 out of 50. So it depends on what angle you're using as your reference angle. And as you're doing these, remember the phrase so, ka, toa. Like when you soak your toe, soak a toa, soak a toe, soak a toa. This will help you to remember the trig ratios. So stands for the sine of an angle equals OH, opposite over hypotenuse. The cosine, ka, the cosine of an angle equals the angles A, adjacent side, over the angles hypotenuse. And tangent, the toa, the tangent of an angle is equal to the angle's opposite side over and the angle's adjacent side. So we want to make a note of this saying and try to remember it, because this is going to save your days. Okay, the next example, all I want you to do is use the triangle on the right to find the trig ratios. So let's pause the video and see if you get what I get for the sine of angle A. And the sine of angle A is equal to 9 over 41. We use A as our reference angle. Sine is equal to opposite over hypotenuse. Opposite to angle A is 9. The hypotenuse is 41. Okay, pause the video. We're going to use angle A as our reference angle again. So we're using A as our reference angle, and we want to find the cosine of angle A. Okay, you should have gotten 40 out of 41 because the cosine of A represents A's adjacent side, so 40, over A's hypotenuse, 41. Alright, this time we're going to use angle B as our reference angle, and we're going to figure out what the tangent of angle B is. Tangent of angle B is going to be angle B's opposite side over angle B's adjacent side. Okay, so the tangent of angle B is going to be angle B's opposite side, 40, over angle B's adjacent side. Remember, adjacent means that it touches the angle, but it's not the hypotenuse, so we can't use 41.